Hello everyone, welcome to our third video, part 3 of this chapter, lesson 1. Today we are going to discuss about an important topic called electronic configurations. Electronic configuration means we should know how electrons are arranged in an atom, and such an arrangement of atom is known as its electronic configuration. So here in this picture you can see the Bohr model of atom of aluminium. Al is aluminium. The atomic number of aluminium is 13. You know that the electrons are arranged in orbits. First orbit, which is close to the nucleus, is called the K shell. Then the second orbit is the L shell. Then the third shell is the M shell. And you also know how many electrons are there in each shell, isn't it? So in K shell there are 2 electrons, in L shell maximum 8 electrons, like that. In aluminium, the outermost shell, this M shell, it is known as the valence shell. The outermost shell of any atom is known as its valence shell. Here you can see that there are 3 valence electrons, and the electrons in the last shell is known as the valence electron. So K shell, L shell, M shell. K shell 2 electrons, L shell 8 electrons, and M shell 3 electrons. And the representation of these number of electrons in each shell can be written like this: 2, 8, 3, isn't it? 2, 8 and 3. This is known as its electronic configuration. Okay, electronic configuration. So what is electronic configuration? Electronic configuration shows how the electrons are arranged in a shell or orbit. Now let us see why we are studying this electronic configuration and why it is important. You know that every atom tries to remain stable. It tries to remain in stable form or stable state. And most of the electrons, not the smaller ones like hydrogen, helium, but little higher ones, they try to achieve this stability by having 8 electrons in their outermost shell. They try to achieve their stability by having 8 electrons in the outermost shell or in its valence shell. I am talking about little higher elements, not the smaller ones. And this ability of electrons to attain stability by having 8 electrons in the outermost shell is known as octet rule. Octa means 8 and octet rule. By following this octet rule, these atoms try to reach a stable state. And to attain stability or to complete this octet rule, what does these atoms do? Sometimes these atoms lose, gain or share electrons during chemical reaction. They share, lose or share electrons during chemical reaction. And this number of electrons which an atom lose, gain or share is known as its valency. So what is valency? The number of electrons that an atom can lose, gain or share during a chemical reaction is known as its valency. Sometimes to reach its stable form, it may lose 1 electron, 2 electron, like that. So how many electrons it lost to attain stability is called its valency. Okay, now I have shown here the formation of sodium chloride. Sodium chloride is formed when sodium atom reacts with chloride atom to give sodium chloride. Now look here, sodium has an electronic configuration of 281. So this is its last or valence shell. In order to attain octet state, it should get 7 electrons, isn't it? Then only it can have the configuration of 288. But gaining electron is not that easy, so it cannot get 7 electrons. But instead of that, what will sodium do is to attain stability, it will donate this one electron. It will donate this one electron and attain stability by becoming 2,8 configured. Now when it reaches 2,8 configuration, sodium is stable. Now here you can see I have put a plus sign here. This plus sign indicates that sodium has lost one electron. Sodium has lost one electron. Okay, hope it is clear. So 281 was the electronic configuration of sodium. It lost one electron and became stable by attaining the state of 2,8. Okay, now let us come down. Here you can see chlorine. The electronic configuration of chlorine is 287. Here this chlorine atom needs one electron so that it can attain the stable electronic configuration of 288. 288. So when sodium and chloride reacts together, or sodium chlorine reacts together, sodium loses one electron, thus getting a plus charge, and chlorine accepts that electron and becomes 288 and attains a negative charge. Thus these two atoms combine together to form sodium chloride. This is what happens during chemical reaction. They attain their stability and becomes a compound. Now here you can see Na plus Cl minus, isn't it? So these are atoms, but they have charge on it. One have a positive charge and other one have a negative charge. And such atoms which has a positive or negative charges on them, they are known as ions. They are known as the ions. What are ions? Charged atoms, or the atoms with positive or negative charge on them, are called ions. They are the ions. They are atoms, but they have charges around them. We have seen in this example that sodium has a positive charge and chlorine has a negative charge on it. So this is sodium ion and chloride ion or chlorine ion. And you have to learn the name of these positive and negatively charged ions. So positively charged ions, which are formed by losing of electrons, are known as cations. So how can we remember the names? It is very easy. Positively charged cation, PC. We know personal computer. So in order to remember, you use this tip. P stands for positive and C stands for cations. So positively charged ions are known as cations. Positively charged ions are known as cations. And negatively charged ions are formed by gaining electrons, and these electrons are known as anions. Negatively charged ions are known as anions. So sometimes when you fill forms, you written Na, not applicable. So you can remember negatively charged ions are anions. Na stands for negatively charged anions and Pc stands for positively charged cations. Positively charged ions are called cations. We remember it by the short form Pc, and negatively charged ions are known as anions. We remember it by the short form Na. Okay. Now in this example we have seen that sodium loses one electron. So this ion here, sodium ion, is known as monovalent, that is one electron it has lost. Oxygen gains 2 electrons, so it is a divalent. Di means 2. Aluminium, in order to attain stability, it donates 3 electrons and attains stable state by losing 3 electrons. Al3 plus is formed, so aluminium is a trivalent ion. So depending on the number of electrons lost, these ions can be monovalent, divalent, trivalent, etc. Okay. Now I already told you what are valence electrons. Valence electrons are nothing but the electrons in the outermost shell. Hope it is clear. Okay. Now we have seen difference between what is a valence electron, what is valence shell, what is valency. Now another important topic, variable valency. Variable valency, what does it mean? It means that certain elements like copper, iron, they have different valencies. Sometimes copper shows Cu2 plus, Cu plus or Cu2 plus. Iron shows 2 plus, Fe2 plus or Fe3 plus valency. And how is it possible that atoms show variable valency? It happens because sometimes an atom of an element loses more electrons than that is present in their valence shell. Sometimes electrons are lost from their shells which are not the last ones, that is penultimate shell means the shell just before the last shell. They may lose electrons from here and here also. That is why certain atoms show variable valency, because due to losing of electrons from their penultimate shell means the shell just before the last shell, also they lose electrons, and because of that they have variable valency. In this table you can see different elements which shows variable valency. Copper, I already told you, it can have +1 valency, or sometimes it can have +2 valency. And here 2 is greater, isn't it? So it is showing higher valency, this is lower valency. And when an atom or element shows lower valency, we add OUS as the suffix. When copper reacts with oxygen, it forms cuprous oxide. When it reacts with chlorine, it forms cuprous chloride. Why cuprous? +1. And at the same time, when copper loses 2 electrons, that is, this valence is higher, 2 is a greater number, isn't it? So when it loses 2 electrons, it forms cupric oxide. We add IC, the suffix IC. Cu stands for cuprous or cupric, based on the number of electrons it loses. Okay, cuprous and cupric. OUS when the valence is smaller, IC when valence is greater. Similarly, iron, it can show dual valency, one is +2 and other one is +3. 2 is smaller than 3, so when oxygen reacts with iron, it forms ferrous, OUS. Again, valency is small, so you add the suffix OUS. Ferrous chloride, ferrous oxide. And when it reacts with oxygen, 3 molecules of oxygen, it forms ferric oxide, IC. When the valency is greater, we add the suffix IC, ferric oxide, ferric chloride. Mercury also +1 and +2 valency. Its name is mercurous chloride or mercurous oxide, then mercuric chloride or mercuric oxide. Hope it is clear. Okay, now we are coming to an important part. What is a chemical formula, or what is a formula, or what is a molecular formula? We have seen that all the elements are represented by certain symbols, isn't it? It may be an atom or a molecule, whatever it is, we represent all these elements or atoms or molecules in the form of symbols, and these symbols are known as the formula or molecular formula. Okay, then certain elements, they have 2 atoms which combine together to form their molecule. They are written like this, H2O2 N2, isn't it? So these are the molecules of, or the elements of these atoms. Now here this is a compound because it is formed of nitrogen, hydrogen, chlorine, isn't it? So this is ammonium chloride. Ammonium chloride is formed of 1 atom of nitrogen, 4 atom of hydrogen, 1 atom of chlorine. So main use of this molecular formula is it shows how many atoms are there in that compound or in that element, isn't it? Now I have given here an example to do, very simple example or exercise, a small test, not test, a small exercise for you. Try yourself. Write the number of atoms in the following compounds: Na2CO3, 2H2O, Fe2O3. What you have to do is write the number of atoms in this in the description. Okay, hope you understood what is formula. Okay, now what is the importance or significance of molecular formula? The molecular formula represents both the molecule and the molecular mass. Molecular mass, you can see that NH4Cl, 4 is written below, isn't it? So by looking at that, we can easily understand what will be the mass of that compound. Okay, we can understand the molecules in it and the molecular mass of the compound. And secondly, number of atoms present in one molecule of the compound. There also we can understand which are the different atoms, how many of them are there, that we can clearly understand. Then the ratios of the respective mass of the elements present in the compound. We can compare the ratios also, isn't it? So these are the three important points that you should keep in mind about the significance of molecular formula. All these are the basics of chemistry, so remember it well, study it well. Okay, the next topic is radical. We have seen that molecule of a compound is made of two parts, isn't it? For example, HCl. HCl has two parts, one is hydrogen and the other one is the chloride molecule, isn't it? So hydrogen and chloride. So potassium is one radical and chloride. Sometimes in the place of hydrogen it can have potassium also. I have written a potassium. So hydrogen, chloride, potassium, again chloride, and all these things are part of a compound. So hydrogen is one radical and chloride is another radical. Potassium is one radical, chloride is another radical, isn't it? So these are the parts of a compound. Now how can we define what is a radical? What is a radical? A radical is an atom or a group of atoms of the same or different elements that behaves as a single unit with positive or negative charge. What's a radical? It is an atom or a group of atoms of the same or different elements that behaves as a single unit with positive or negative charge. Let me show you. Na plus. It is a radical with only sodium ion. But now there is another radical, SO4 2 minus. This is the sulfate radical. Here you can see there is sulfur atom, oxygen atom, but they together act as one unit. They together act as one unit, and such an atom or a group of atoms is known as a radical. What is a radical? It may be an atom or a group of atoms of the same or different elements that behaves as a single unit with a positive or negative charge. Here you can see sulfur does not have a separate charge, nor oxygen have a separate charge, but this 2 minus is the charge of this group SO4. They are behaving as a single unit, sulfate unit. Okay. Now sodium, magnesium. Here there is only sodium atom, magnesium atom, and such a radical which is made up of only one type of atom is called the simple radical. And SO4 2 minus, as already I shown you, it is made of sulfur and oxygen atom, but they behave as a single unit. This type of radical is called compound radical. What do you call these types of radicals? They are known as the compound radical, sulfate radical and compound radical. Hope this topic is clear to you. Read it well and study well. And before I conclude this video, please like and subscribe to my channel, and I am open to your suggestions. Please let me know if any changes are needed or there. Thank you.